Hi everyone, and welcome to today's Couchbase webinar introducing the new Golang SDK. My name is Ali, and I will be moderating the webinar today. Before we get started, just a few housekeeping items. One, if you have any questions at all during the webinar, feel free to pop those into that question box on the left-hand side of the console, and we will do our best to get to them. We are recording this webinar, so you'll receive a link to the on-demand version to watch at your convenience. I also dropped today's slides into the resources folder. That's that green button at the bottom of your console, so you can feel free to download those if you would like a copy. And last, at the very end of the webinar, we hold a very short survey just asking for your feedback, so we would appreciate you letting us know what you thought. So with that, I'm excited to introduce Todd, who's part of our engineering team here at Couchbase. Todd is going to talk to us a lot more about our brand new Go SDK. So with that, I'm going to turn things over to you, Todd.
Thank you. Hi, everyone. Today's an exciting day for us. Our 1.0 GA version of the Golang SDK is being released today. So it's very exciting and appropriate for us to be doing this on the same day that happens. So let's talk about SDK as a Couchbase. What we're going to do is we're going to have a brief intro, kind of walk through this. We'll talk about the Couchbase Core architecture, and we'll talk about the core Couchbase SDK API, and then we'll also talk about the Couchbase Go SDK, and then we'll go through a short demonstration that shows our try sample application that you may be familiar with on other platforms. And in addition to what Ali said, we will send some follow-up information on locations where you can download the GitHub repository and the tutorial. So I'm going to go ahead and get started, and if there's any questions, please feel free to type those in the comments window, and we will address those as they come up. Don't feel the need to wait till the end. So anyway, we'll go ahead and move through this. So this is exciting. Typically in the past, what we've had, our core SDKs have been Java, .NET, PHP, Ruby, Python, C, and Node.js. And in addition to that, now we have the Golang SDK. And why this is so important to us is, as a company, we've made such a significant investment into Go as an architecture. All of our new services that we're developing for Couchbase that you may be familiar with, such as Nickel, such as our new full text platform that we refer to as Blevy or CBFT. These are all built using Go as a core language. So we put a significant investment and belief into this technology, and it's paying big dividends for us, and it's very exciting for us to have this as an SDK that's available now. And I want to talk about what this means from a release cycle perspective. Each SDK, we use Semver, and in doing that, we do major releases, usually anywhere maybe once to twice a year. And these are core architectural API changes within the product. And then after that, we have minor releases and minor updates. So usually on the first Tuesday of each month, you'll see a minor update with latest bug fixes in there. And we always encourage you to use the latest and greatest of what our SDK offerings are out there, as we spend a lot of time investing in quality assurance and quick fix engineering, and we make sure that we're always delivering you, the most value as a customer with these particular releases. And in addition to that, we'll move through this real quick. Let's talk about Couchbase as an overview. I won't spend too much time on this, but if you're unfamiliar with Couchbase, it's worth just a really brief overview on what Couchbase is. What we are is we believe we're the complete data management solution. We strongly believe in what we do as layer consolidation, where we have a high availability cache that's built into the product. We're a key value store, a document database. We have our embedded mobile product, and also now we manage synchronization intelligently through our Sync Gateway platform. And there's lots more information on this on the website, and I strongly urge you to read through what we do there and look at some of the use cases and how those might apply to your own particular use case and needs. In addition, at its core, Couchbase 4.0, which is the latest and greatest version of our product, the final release candidate for that was released last month. And in addition to that, we have the actual official GA big release celebration coming up in October. So this is a very exciting time for us. And what that means is, within Couchbase, one of the things that you always hear us talk about is a single node architecture. We have the core components that you'll see on the left-hand side, which is the cluster manager and the node manager on the right-hand side. And within these, there's 3 independent services that operate within each particular node. The architecture is the same for every node, but it allows you to scale these services independently. And we'll talk more about that in a second. At its base, when you talk about sharding, one of the things that makes Couchbase unique is we auto-shard. We don't require you to develop sharding keys and manage a very complex sharding architecture. We actually handle all of that using CRC32 hash algorithm, and we distribute data evenly across all available nodes within that are assigned to a specific service, such as key value within your cluster. So we don't have to spend a lot of time talking about this, but just wanted to, if you're not familiar with this, it's really, really easy to get started in using Couchbase, and when we go through the demo, we'll take a look at that. What it does for using this hash algorithm, when you actually connect to Couchbase, there's something wrong with the slide here. Apologize real quick. So what happens is, as you add nodes within the cluster, when we rebalance, since we have 1,024 virtual partitions that we call vbuckets, or actually, sorry, partitions that we refer to as vbuckets or virtual buckets, what we do with those is we distribute those evenly throughout the cluster. So whenever you're adding nodes or removing nodes from the cluster, when you rebalance, we automatically distribute those in the manner that best fits within your cluster topology. So for example, if you've got a 4-node cluster and you add or remove a node, if you go from 3 to 4, we'll basically have 256 virtual containers or vbuckets on each node in your cluster. And what this means is, if you have replicas defined, what happens? You've got with your particular client, as you connect to a cluster, it basically has that cluster map within the client at all times. So the client itself, it handles all of the topology changes that happen within the cluster automatically. So if there's failover or anything like that happens, you don't have to worry about what that means from an SDK perspective, other than for your durability or your application requirements. So if there's topology changes and whatnot, the client automatically updates and is able to handle those particular changes seamlessly. And so let's go through and take a look. Sorry about this. So again, these are just some kind of brief overviews of what this means to add and remove nodes to a cluster. We talk about a single logical connection to a cluster. When you initiate your connection from your smart client SDK, all of this topology comes back automatically. And this is something that you don't have to manage where you're talking to information from. As long as you've got a single endpoint that connects in, we basically handle the rest for you. It's very efficient. Failover, if you've got replicas defined within your cluster, failover, we support automatic failover 1 node at a time. And what that means is we don't get into situations where you have like a thundering herd scenario where we just start peeling out node after node after node. That's something that doesn't happen. What we do is we have a threshold that each time a node is ejected from a cluster due to failover, it actually requires manual intervention. And that doesn't mean that somebody has to actually physically log in. We do have a REST API that if you're using automated tooling and whatnot that can do that. And also you can do that as well through Golang if you want. We've got some further information on that on the website where you can actually reset that cluster threshold using the REST API and move on. What's interesting with the last thing we'll touch on with Couchbase and architecturally here is prior to 3.0, we've had these services where we talk about within the cluster the query service, the view service, and the data service, often referred to as key value. What happened previously to version 4.0 and version 3.0, et cetera, was each node in the cluster ran all 3 services regardless. And no matter how you scaled out your cluster, you weren't able to segment any of where that where those workloads were taking place. And if you needed to scale up and scale out, it was every service ran on every node regardless. One of the things that we've done that we refer to as multidimensional scaling with 4.0 is we allow you to isolate on particular nodes where services run. So what this means, again, the smart clients automatically can handle this topology under the covers, and this isn't something you need to spend a lot of time worrying about how your connectivity managed from the SDK. This all happens for you. As long as you've built your cluster in a way that you can connect to it from any node in the cluster, and you basically bootstrap your application, all of the topology changes and how you move services around within the cluster, that's handled automatically. You don't have to worry about any of those topology changes back on your application tier. And let's talk about what the Couchbase SDK is at its core. And this is across all of our SDKs, and of course Golang is no different here. First thing, what does it mean to be a Couchbase SDK? So at its core, we've got the cluster API, which handles buckets, information, opening buckets, info, and some buckets level management operations happen within the cluster API as well. On top of that, you've got the bucket API, which is how you actually connect to a particular instance or a particular bucket within a cluster. And on top of that are the actual APIs for accessing and manipulating data, which is, your CRUD API, which is, get, insert, remove, etc. The view query, and upon that now we also have the nickel query API. A lot of times you'll see the CRUD API often referred to as your document level operations. And when you think about what a document is in Couchbase, all of our SDKs, and Golang's no different, work in JSON natively. That was something prior to the 2.0 SDKs in Couchbase that wasn't exactly the case. There was a little bit of nuance there and how all of these work together. But now, when we think about that, everything operates end-to-end natively in JSON. So this makes the development experience really, really crisp all the way across. And if you're using multiple SDKs, we're able to support that without any issues. Within a bucket API, for actually modifying documents, you've got insert, upsert, remove, append, prepend, and counter. One of the things that we've added within the 4.0 version of the product is enhanced durability. And we don't have a slide on this in this particular presentation, but there's some information on that, on what that means in the website. It's sort of it's our first step towards improving being able to have a much finer granularity control with the consistency model. And you'll see some more information on that as we further releases with the product and what that means. It's a very powerful feature, and it's something that we expect we expect a lot of use and a lot of different features and things to be built on in the future. So within the bucket API, being able to get from replica. One of the things that's interesting on here is one of the high bars that we had for Golang when we came to market was to be able to support all of this functionality that we developed across all of the other SDKs over several years. And that's why, it's taken us roughly it's almost been a year in development that we've had doing this particular SDK just to get it to a level that we're comfortable with and something that we're comfortable with in front of our customers. And we have the full get from replica, we've got get and lock, we've got get in touch. These are all supported within Golang, as you're familiar with maybe in our other SDKs. Query. One of the things that's really exciting about query is Nickel, which is our SQL our type interface query API that's available in 4.0. As that's now pretty much generally available, that's also supported natively within Go. And we'll actually take a look at that when we go through and run the sample application here. So let's talk about why we think this is production ready, in addition to what we just talked about. So full support for Couchbase 4.0. This was sort of the minimum bar. Not only did we have to support all these wonderful things that we've done with our other SDKs in the past, but we also wanted to make sure that when we release 4.0, which is our biggest release ever of Couchbase, that everything in there is supported natively. And let's talk about what it looks like and how this works. So the most important thing, just to get started, is you'll see here within your import section of whatever you're building for your Go application. If you have that reference in there, github.com, Couchbase, and Go CD, this will actually build the Couchbase. When you do go get at the command line, this will actually go out and build the particular SDK and the latest version of that product. And what that means from an architectural standpoint is Go SDK, it's really two parts. We have Go CD Core. At the base, this is our core I/O layer, which is the same in Java and also the same in .NET, and also in our libCouchbase C product. And this handles all of the low-level communication, all the topology changes, etc. Handles all of the things that are very low level to manipulate, things revolving around consistency, connectivity, etc. And then the higher level abstraction that we work in for actually when you're building applications is GoCB that's built on top of that. So just a little sort of topology map beneath there. It's pretty simple, but there's a lot in that Go CD Core package that handles all of the things and improvements that we're building, and it allows us having that abstraction on top. It gives us a really, really powerful developer experience and allows us to build really rich APIs on top of that. And this is something that we've learned from our other SDKs over the years and how to build this. And one of the things that we like to do that's sort of the best practice for when you're building your application is if you actually, when you bootstrap your application, in addition to that, one of the things that you do is we like to use the same connection within the application for handling and for passing in and retrieving information. And the reason for that is each time you open a connection to Couchbase and tear it down, there's a fairly substantial overhead that's involved with doing that. As all of the topology changes and how we bootstrap applications come in, it's important to be able to reuse that connection without having to do that each time. We see frequent support incidents where we actually, people are like, hey, my performance is just terrible. What's going on here? And we look, and each time they do some, CRUD type operation, they actually open a connection and tear it down rather than keep that open from the application. And in doing that, it's an order of magnitude performance degradation by doing that. One of the things that makes Couchbase so high performance is our ability to keep that connection, maintain it, and make it durable in terms of when there's topology changes and anything that happens on the network, we can handle that, and we're able to, manage that intelligently without having to, reopen a connection each time. It's very, very powerful. And so what that means for client connectivity is, if it's a little bit hard to see on the screen, but you can see all of our initial connections for the clients use port 11210. And when they connect to the endpoint on a cluster, any particular endpoint on the cluster, they'll receive something which we use called terse bucket protocol. And you'll see this if you actually look at the REST endpoint that's stated there. For example, if you've got a travel sample bucket, the bucket section there with travel sample or default or whatever bucket you wanted to look at. And in doing that, when you connect, you'll get a list of services that are available for that particular bucket and what port number they're on. And you'll also receive the cluster map back. And again, this is something that all happens under the covers for you that you don't have to manage, but it just gives you an idea of what it's doing when it makes and initializes this connection to Couchbase and manages this for you. It's a really powerful feature, and it's something that, again, we want to make sure that we reuse that connection whenever possible and that we're not trying to tear down a connection and reopen it each time. And let's talk about for fault tolerance. By default, we pull for a new connection. We pull for a new topology map every 10 seconds by default. Within that window, if we receive any notification or any errors that are topology related, we'll go ahead and request a new configuration at that time as well. But we just want to make sure that even if we're not doing that, or even if we haven't received any new connection changes or anything, we just check every 10 seconds anyway. And this is the same in Golang and across all of the other SDKs. So let's go through a demo, and we'll kind of talk about what we're doing here. First thing we'll do is, in order to have Couchbase installed, I'm using Mac OS X, and I've downloaded the latest version that's available on the website for running on Enterprise Edition on the Mac. And I'm going to go ahead and share my screen. And make sure we can all see this. A second here. Okay. All right. So first thing, when you log into Couchbase after you've ran through your initial cluster setup, I'm going to go ahead and add the travel sample bucket that comes as part of the product. This is shipped with every version of the product now. And if I go and add that, it's under the Settings tab, and you'll see sample buckets. And there's 3 different sample buckets that we currently are shipping with the product. I'm going to go ahead and pick travel sample. Go ahead and create that. And while that's creating, I'm going to bring up my Golang application here. I'm using the Atom editor with the wonderful Go plugin, which is a great way to get started in Go if you don't have an IDE already for this, it's a pretty neat little tool to use. Definitely take a look at that. Again, so at the top here, I'll walk through what we're doing. We basically, the first thing is obviously we have the Couchbase reference here to the Couchbase SDK. I'm using format, time, encoding JSON. This is great for encoding and decoding of JSON information. Net HTTP, this is the awesome package in Golang for handling HTTP requests and building a really, really simple HTTP router and REST API, which we have below. Strings and string conversion, math, and then I'm also using errors. And one of the other things I'm using here is a great implementation that's available on GitHub at this location for JSON Web Tokens. Something that if you haven't looked at JSON Web Tokens, take a look at this. We've been using them across the SDKs when we're building demos, and it's a really powerful way to build authentication, and it's really simplified and easy. So at its core, when we go down, one of the things I want to point out here, pardon the fast scrolling, is you'll see we've got we basically have a pointer to the Couchbase bucket, and then when we actually initialize this under main, so I'll cruise down here, pardon the scrolling again. When we actually initialize our Couchbase connection, we basically open the connection to Couchbase, and we basically open the bucket. And by doing this, when I basically assign bucket to that particular cluster connection, I'm basically reusing this now throughout the application. So I don't have to reopen or tear this down or whatnot, and I'm basically able to use that from wherever I'm doing requests within the application that need to talk to Couchbase. And if we actually go ahead and run this from the command line, I'll show you guys what it does. Oops. So want to bear with me 1 second. Looks like I've got a little environment challenge here. Clean that up. Okay, sorry about that. Come back here. So one of the things we are frequently changing between different versions of Go for testing, and I will mention that this is built currently under Go 1.5, so that's why I had a little bit of environment challenge. So now if I go ahead and run this, why am I still not seeing this? Oh, there we go. Okay, so now if I do Go, and go, there we go. So now when this comes up, this will basically start a server on port 3000, which you can see, this is basically the line that I'm outprinting here. And I've got a few really primitive routes defined that have functions here within Golang. This is basically allows me to log in, where I use and retrieve a JSON Web Token back. Allows me to find particular flights, allows me to find particular airports that I want to fly from, and based on that, I'm able to book something using our handler for actually, I will show you guys where that is, for actually posting to the user login. So let's go ahead and walk through what this does first. So I come back here and put a new now. So if I just pick a username, I'll just pick me, or let's say admin, just for argument's sake. It'll be easier to see this. And click new user. So what this does is this walks through, basically posts a new user into Couchbase and gives me my login credentials, and we can actually look at what happens within the particular data bucket that we've built, the travel sample data bucket there. We can actually go and look at the documents from within this admin UI, and you'll see here's my user. One of the things there, it basically lists my JSON Web Token. Again, this is all encrypted, so from the application. So if you did have access to this particular terminal in a production environment, it wouldn't really do you much good to get the user credentials, as the token that's for authentication is completely encrypted and it's using a JSON Web Token. So we go back, and if we actually look at a particular flight, so this is a type ahead in Angular that's bound to do a simple query in Nickel. So if I pick London Heathrow, for example, boom, Heathrow comes up, and if I pick LAX, do that here, and whoops, I'll do that again. So, and also, in addition to this, it does handle more complex type of queries using like statements. So, for example, if I picked Portland, et cetera. So it's not just looking at single values. It's using a like under the covers. And as we, improve on queryability and add things like full text, you'll be able to do a lot more advanced searches from within Nickel. And what this does under the covers, if we actually look at that particular route, so if we look at that particular route is the airport and find all, and you'll see that we basically handle, when we see that particular route, we go to this particular function, which is the airport handler, and we'll scroll up to that, which is, so let's walk through. It's worth talking about how this works under the covers. So the very first thing we do is obviously in our function signature, we've got response writer, and we also have the request that's coming in. And we basically define a string here to start with, which is our query prep. And what we do is we want to take a look at the length of that string. Instead of just issuing like a blanket like statement, what we want to do is we want to make sure that we, based on particular lengths of the string that we're searching for, we do different things. And so the first thing in this example, like you'll see if the string's if it's basically 3 characters long, that's probably an FAA name like LHR or LAX or PDX or one of those common FAA 3-letter acronyms that we're all familiar with. So if that's the case, what we do here is we issue a select statement using Nickel and our query API. And in doing that, we convert it to upper, so we don't have to worry about what case it came in, because some people may type it in, LAX or uppercase L, lowercase a, et cetera. And then we go ahead and search for that. Same with 4. So if we see if it's 4 letters long, it could be different things. It could be an ICAO code or ICAO code. It could be an airport name, and we want to make sure that we handle both of those cases. So what we do is we search for either one of those based on that, so you can see there. And then if it doesn't match either one of these, we fall out, and we just issue a like query generically against the particular bucket. And in doing that, we go ahead and issue our query. We use GoCBQ, and we first use which is the new Nickel query. We have to define that it's actually a particular Nickel query that we're going to issue to Couchbase, and there's information on what that means, as in the Go docs. So you can take a look at that. But we actually have to tell Couchbase that it's a Nickel query. And then what we do is we use the bucket API, and we go ahead and execute that Nickel query that we defined above. And when we do that, it basically, you'll see if there's any errors or whatnot, we're checking. That's what that this check right below here is, that if there's, because what we get back each time is we get our pointer to the interface for whatever rows are returned, and if there's an error, and we're going to look and see that there's no error, then we're going to move on. And if you see here also, you'll see nil, where I'm not passing anything else into Nickel query. This is a parameterized collection that you can actually issue things very specific to Nickel on, for example, timeouts, and if you're doing anything that's related to consistency that's different from standard. And why this is worth mentioning is Nickel and Couchbase in general is really, really good at respecting timeouts. So if you issue a query that's going to, run across 10 billion records and take 2 days to finish, and you have a timeout that's set to 75 seconds, if the connection was just, if we got something back that said, hey, this has exceeded too long, timeout, but it kept running on Couchbase, that would, paralyze resources on the cluster. So what it does is, as soon as the timeout is propagated back to the application over REST, it actually also stops running that process for doing that query within Couchbase itself. So it's a very intelligent, very well-managed process, and it's something that we spend a lot of time testing, and we're obviously going to add additional functionality in later on down the road. And so, assuming that we didn't have any error here, and if we did, we would just output, since this is just a really simple application, to the terminal to see if there was anything wrong. What we're going to do is we're going to define a instance of our airport struct and also a row based on that. And then we're basically going to iterate through the row collection and return those back to our application. And we just basically use JSON Marshal, send those back, and write them back. And again, since the marshaling that's built into Go is really powerful, and since we're operating in Couchbase in JSON, and then our front-end Angular piece also is looking for JSON, it makes it really easy to get that back. So now, after we've done that, we'll want to pick a particular day, and we'll go ahead and do that. So we'll say, and you obviously see have the option of one-way or round trip here. And one of the things that's really neat, you can actually see what it's doing under the covers from this particular screen. If you click narration, you'll see all of the API calls that are being made for you down below here. One of the things that within some of the other SDKs, which we haven't brought to Go yet, is we actually give you the ability to see the output to the terminal and what's running within the application itself. But right now, we're basically only looking at the API calls from within Go. But we expect to improve on that sometime within the next few months, so you'll be able to see that as well. So now what we can do is we can look for particular flights. And one of the things that's important for mentioning about Nickel is as these results come back, they're streaming interface. So, we get these back in a very efficient manner, and we're not blocking anything. This is all done asynchronously. And I can go ahead and choose one of these and basically go on to the next step of booking the flight. So let's look at what this particular call is under the covers. So what happens when we find a flight is if we look down here again in our main function where we have our handler, if we say, okay, we want to basically say flight path, and we want to find all. That's how flights work within this particular application. So let's go to the flight path handler function, which is up here. Now there's a lot going on in here. This is a pretty complex function. This is the most complex part of the app. But what's really worth mentioning and what I think is really exciting within this particular function is where we actually do the query preparation and when we actually execute. First thing we do is, again, we define a bunch of instance variables and things that we use up at the top. I won't go through the depth into those. And then we basically get from our query string, we get from and to, and then we also look and get the leave and return values as well. And when we do that, one of the things that we do is we look at, we grab the leave value each time that this request comes in, whether it's a one-way or return flight. The system doesn't really care. It just is looking for a date that the particular flight is on. And then the front-end application Angular piece handles that for you. It actually issues that and then basically converts that to a day of the week by 0 and then enables you to grab that from Couchbase. And when you look here, what we do is we do a basic union to get our geo information on where this is within Couchbase. Then we actually use you see this, we'll say we grab the from airport, and then we union this to the to airport and get the geo information. And then once we have that, we actually convert this using the _sign function and get the mileage. So we actually build the pricing and the duration of the flight. We actually build that in real time from the application. This isn't something you would do in production. It's just something to show you the flexibility of how this can be done in Couchbase and use things like geo within Couchbase. So it's very, very powerful. Again, we prepare in Nickel, we actually do the query preparation locally, and this doesn't mean we're using a prepared statement. We can talk about that in a second. I was just saying we actually prepare and tell the application that we're using a Nickel query, execute that, and run through and grab our information. Then we build the distance down below here, and then once we've got all of that wonderful information, we do a really advanced query here using joins within Couchbase to grab all of the airport information, the flight information, what type of aircraft it is, and bring that back and publish that back to our front-end application. There's a lot going on here. We don't need to walk through that in detail, but I just wanted to sort of show you guys how all this works and what's happening under the covers. And one of the things that we spent a lot of time developing for the 4.0 release for Nickel is the ability to use prepared statements. What that means is you're actually freezing an execution plan in time. I don't have an example of that in here because it's something that you're generally using in a performance based application after you've sort of got your prototyping done, and this is something that you want to use and you want to share or you want to improve upon performance, then you start using prepared statements. But there's a fairly substantial amount of information on that on our website, and we've also have that support natively built into Golang. And with that, again, we'll send out some follow-up information on where you can grab all this and how to get started. And there's a great tutorial that walks through everything that we just talked about on the website, along with a lot of documentation. And if there's anything else, please don't hesitate to reach out to us at any time. And with that, I'll hand it back to Ali.
Thanks, Todd, for an awesome webinar. Sorry about that. So just a reminder, everyone on the line, thank you again for listening to today's webinar. I did drop the slides in the resource folder, so you can go ahead and grab those at any point. A short survey will pop up right after the webinar is over, so we appreciate you giving us your feedback. And last, we did record this webinar, so you will receive a link to the on-demand recording. So with that, I want to thank Todd for an excellent presentation on the new Go SDK. We hope you all learned something, and we hope to see you at the next Couchbase webinar. Thanks again.